Welcome back to Applied Mathematics. In this video, I want to talk about scientific notation. Scientific notation is a tool used for expressing very large or very small numbers without wasting or even running out of paper. To see what I mean, let me go to my calculator, and I'm going to introduce you to my favorite number. I encourage you to grab out your own calculator, especially if it's a different calculator than this one, and calculate this value as well. My favorite number is 111,111,111 squared. And when I punch that number into my calculator, I get something that starts off 1.23. And I hope that you look at 1.23 and immediately say, that can't be right. We are squaring a number that's like 100 million. It has to be a lot bigger than 1.23. And then after you come to that realization, I hope that you look across this number and see at the end, there is a letter E that shows up in the number. That E is the indication that what we have here is scientific notation. If by hand I were to calculate 111,111,111 squared, it comes out as 12 quadrillion 345 trillion 678,987,654,321. If you're bored and you want to use up a sheet of paper, multiplying that out by hand is actually kind of fun. Also, you start to see why it's my favorite number. If you read across the digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. The issue with this number is that it's too big. There are 17 digits in this number. My calculator is capable of showing 12 digits, and at that point it runs out of screen. So we need to truncate the number in order to express it. So my calculator has truncated it the way that it has. I'm going to actually truncate it even further because, well, let's be honest, for almost any practical application, 3 or 4 significant digits is enough. So I'm just going to take the first number, a 1, put in a decimal point, continue on with the next couple of digits, 2, 3, 4. Then I'm going to multiply times 10. 10 raised to a power. That power is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The number of digits that occur after the first digit in a number, stopping at a decimal point if it continued past the decimal point. 1.234 times 10 to the 16. That's what the E16 on the calculator display means. Right? Displaying times 10 to the 16 is a little bit cumbersome, so calculators and computers use this convention of a capital letter E means times 10 to this power. And we can also look at things in the other direction. If I have this number, 1.234 times 10 to the 16, right, I have rounded it. I have lost precision from the original value, but I can still extract most of that information. To take a number that's in scientific notation and rewrite it in standard notation, you write down the first digit. Then you are going to need, in this case, 16 additional digits, however many the number that is in that exponent. So I'm going to need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 more digits. I start filling in with the digits that I have. 2, 3, 4. At that point, I have run out of information, and I fill in everything else with placeholders. I'll come back in, I'll put my commas every 3 digits the way that we do in the United States and nowhere else in the world. And I get that this number, not exactly, but approximately 12 quadrillion, 340 trillion and change. Right. I've lost information, I have rounded, but the important bit of it is still there. Right. I can also do that with small numbers. If I have something like 0.0000375, in order to write this number in scientific notation, I look for the first non-zero number. In this case, it is a 3. I then put in a decimal point, and I include the rest of the numbers that I have, 7, 5. If there were significant zeros, I would include those. If there's non-significant zeros, we leave them off. Then I multiply times 10, and I count the number of zeros. One thing to pay attention to here, the way that I explain this, you need to make sure that that leading zero is there. If you don't have a leading zero on the number, it starts with a decimal point, the rule that I am about to explain does not work. There are 2 conventions in mathematics. Some mathematicians who say that leading zero must always be present. Some mathematicians who look at the leading zero and say, why are you wasting your time? I am of the former category. All right, but we're just going to count the zeros. In this case, there are 5 zeros in front of a number, so it's going to be times 10 to the 5th. But we don't want it to be confused for the positive value that we have over here. So to emphasize that we want this to be a small number, it's actually going to be times 10 to the negative 5th. All right, this particular number is actually simple enough to work with that I probably wouldn't use scientific notation. But there are a number of places where scientific notation is very important. (1.602 times 10 to the negative 19). This is the charge in coulombs of a single proton. To write this number in standard notation, I look at the exponent. I realize it's negative. That tells me that I'm going to be dealing with stuff after a decimal point. So I write down 19 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 of them. I put the decimal point after the first one, so that I have a leading zero. And then way at the end, I write out all of the digits that are given to me in the value in scientific notation, 1602. And I think that that example really shows why scientific notation can be so valuable, because it is much easier to write 1.602 times 10 to the negative 19 than to write 0.000000000000162. And it's also much easier to remember. All right, so we have numbers in scientific notation. Calculators, once again, are going to be our friend. If I have numbers in scientific notation and I'm trying to perform operations on them, I'm going to turn to my calculator for help. let's just put a quick example in here. 3.75 times 10 to the 7th, 9.83 times 10 to the negative 4th, and let's put that all over 6.12 times 10 to the 27. And let me get my calculator back up on the screen. And once again, this varies from calculator to calculator. But I don't want to write out times 10 raised to a power. That actually can cause problems in certain circumstances on certain calculators. Instead, I want to look for the scientific notation button. On my calculator, it's this button right here labeled as EE. On some calculators, especially if you have a calculator that has fewer buttons, instead of finding a button for EE, you might find it hidden in the menu. See if this calculator actually shows up if I hold it here. Yeah, that seems to mostly show up. Here I have another calculator that I just happen to have laying around. Once again, there is an EE button, but it's not the button itself. It's this little bit in blue right above the button. So you have to hit second and then that key to get the exponential for scientific notation. Anyway, I've got a fraction. I've got 3.75 times 10 to the power. I use E to represent times 10 to the power. I type in 7. Then I've got 9.83. I use E to mean times 10 to the power, and my power in this case is negative 4. Then I move down to the denominator, and I've got 6.12 times 10 to the 27 power, and my calculator will tell me that is 6.023 etc. times 10 to the negative 24. All of these values had 3 significant digits, so I round my result to 3 significant digits, and I will write it in as 6.02 times 10 to the negative 24 power. If you got 6.02, but a different power than negative 24 in your scientific notation, that's probably a sign that the key that you tried to use is not the scientific notation key. You probably tried to use a multiplication key, and the order of operations is going to mess with it. Very specifically, this bit of multiplication in the denominator of the fraction can be problematic. So look around for a different key for that. Make sure that you can find a way to enter something like this into your calculator and get the same result I'm getting. All right, but let's get that out of the way and let's look at one other. When it comes to addition or subtraction, that's where things can get really weird. Consider 7.325 times 10 to the 17 minus 9.865 times 10 to the 15. I'm sorry, I'm looking at the wrong problem. I jumped halfway through 2 problems. That's not the one I want to do. 7.325 times 10 to the 17 minus 9.8 times 10 to the 16. If I punch this into my calculator, it will certainly give me a solution. 7.325 scientific notation 17 minus 9.8 scientific notation 16. And my calculator tells me that this is 6.345 times 10 to the 17. But where do I round that? Oh, come on. There we go. Where do I round this value? it's not immediately obvious, because what are the place values of the numbers that I started with? Right? 7.325 is precise to this 5, but what's the place value of it? 9.8 is precise to this 8, but what's the place value of it? Right? It's not the 10th place, and it's not the 1000th place, because the scientific notation has moved things around. Once again, there are several different ways that I have seen people try to explain it. The most common one that I see is, you should just write that out in standard notation. Yeah, you should write out all 18 digits of this number and all 17 digits of this number and figure out what's going to happen. That sounds painful to me. So instead, I'm going to do things a little bit differently. The first digit of the number is in the 10 to the 17 place. The second digit of this number would be one place value smaller, which is the 10 to the 16 place. This is the 10 to the 15 place, and this is the 10 to the 14 place. Just one place value smaller, one number smaller in the exponent every step that you take. Likewise, in my second number, that 9 is in the 10 to the 16 place, which makes the 8 here in the 10 to the 15 place. So which of the numbers is less precise? The one that is rounded to the 10 to the 14, or the one that's rounded to the 10 to the 15? 10 to the 15 is less precise than 10 to the 14. So 10 to the 15 is how we're going to round our calculated result. I'll go ahead and write the whole thing out the way my calculator read it off to me. 6.345 times 10 to the 17, and I'll go through the same thing. This is the 10 to the 17 place. This is the 10 to the 16 place. This is the 10 to the 15 place, and that is the 10 to the 14 place. I just determined that I wanted to round to the 10 to the 15 place because that was the worst precision that I had in the values that I started with. So I round to this digit. The 5 after it says round up, and we'll call that 6.35 times 10 to the 17. All right. If you've not seen this sort of thing before, it can take a little bit to get used to. There's no arguing that. But you should be able to get used to it. It just takes a little bit of practice and a little bit of thinking about it. So try a couple of problems out of the homework, see where you can get to with that. I'll see you in the next video.